Welcome back. Previously we were discussing about different case and application situation with regard to binomial distribution. Let us continue with the same categories. Next one. Fitting a binomial distribution. So until now we have learned about the binomial distribution or the meaning of binomial distribution. Remember, binomial distribution, this concept was introduced by a statistician, James Bernoulli, otherwise known as Bernoulli trials. Because in binomial distribution we are studying in detail the probability of various events or trials under various random experiments. So sometimes we may use a term Bernoulli trials. Bernoulli means it's the name of the person who have introduced the concept of binomial distribution. So in the Bernoulli trials or a binomial distribution case, you will be studying in detail the probability of certain events that may or may not occur. So what kind of events are studied in a binomial distribution situation? We will be dealing with situations where mutually exclusive situations are considered. So what is the meaning of mutually exclusive? I hope you all know the concept of mutually exclusive. Mutually exclusive is with regard to the occurrence of a event that is success or a failure. Because in binomial distribution we are studying the occurrence of an event, whether it is a success or a failure. So in that sense it is a mutually exclusive event. So in Bernoulli trials or a binomial distribution situation, we are identifying the probabilities of each events with regard to the case under the study. So next one, fitting a binomial distribution. How a binomial distribution can be used to identify the probability of each of the events of a random experiment. So there are certain steps with regard to that. Before we go into further, you need to identify and understand various concepts. First one, determine the value of P, Q and N. P, we all know what is the meaning of P. P is the value or variable represents the success. Q is the variable that represents failure, and N is the number of trials. And substitute those values or the data with regard to P, Q and N in the binomial distribution function of NCX into P raised to X into Q raised to N minus X. We have learned all these things, so that we will get the probability function of the binomial distribution. This is how we are identifying the probability of a certain random events. So first one, you need to identify P, Q and N. Next one, once you identified P, Q and N, remember the X, whatever the number of events, you have to consider the one more event, that is 0. So whenever you are asked to find the probability of a certain number of events, you need to first find the probability of event that will not occur, that is X equal to 0. So if it is 6, instead of writing 1, 2, 3, 4, 5, 6, you have to also consider 0. So you will begin with a 0. So putting X equal to 0, 1, 2, it may be 3, 4, 5, 6 or any infinite number, not infinite, finite number. So the function will be NCX into P raised to X into N minus X. We have done many cases with regard to that, and we get N plus 1 terms. N plus 1 terms means including 0, that is what N plus 1 terms. If there are 6 items, that is N equal to 6, you have to find the probability of 7 items. That is, you have to find the probability of 0 also, 0 event also. That is what N plus 1 means. Next one, multiply each of the terms. Each of the terms means each of the probability by N. N, otherwise known as total frequency, to obtain the expected frequency. So before we go into total frequency, expected frequency like that, the thing is that a question, you may come across a question where a certain event or a random experiment will be given, associated with its frequency will be. Frequency means occurrence, what are the chances of occurrence of each of the events, that is frequency, or otherwise known as F. And we have done numerous examples with regard to X and F. X means the details of the events and F is the frequencies of that particular events. So X and F will be given. X and F means X is the random experiments or events, and F is the actual frequencies of that events. Actual. Someone might have done an experiment and the actual events has been recorded. But you need to find out the expected frequencies of each of these situations. That is how you are going to do, or you are going to deal with fitting a binomial distribution situation. That is, you will be given X details and you will be given the details of corresponding F, that is the events and its actual frequencies. On the basis of that, you need to find the expected frequencies. And how you are going to find the expected frequencies? On the basis of binomial distribution. That is what fitting your binomial distribution means. Let us try another question. 8 coins were tossed together. N is given, small n is given, and 256 times. 8 coins were tossed together and it was tossed 256 times. So capital N is known as 256. Find the expected frequencies of a head. What are the chances of occurrence of head? Find the mean and standard deviation. So this is a question. You are asked to find the expected frequencies. How you are going to find the expected frequencies? So let us first of all find out the details that can be extracted from the case. We know that the probability of getting head or the success of getting head is 50%. So probability of head in a row is 1 by 2. So naturally you will get the value of Q, that will also be 1 by 2, and N is 8. So we got P, Q and N. Now we have almost all the details that can be used in the binomial distribution function. So let us try out each of the events. It is said that 8 coins were tossed together. 1, 2, 3, 4, 5, 6, 7, 8. That means if 8 coins are tossed, what are the probability of getting 1 head out of 8? Next one, you might get 2 heads. You might get 3 heads. You might get 4 heads, 5 heads, 6 heads, 7 and finally 8. Remember, apart from that, there is one more event also. If you are getting none heads, if you have thrown 8 coins simultaneously, you may not get any of the coins as head. So you need to find the probability of each of the individual items. So for that we will be using binomial distribution, and on the basis of that you have to find the expected frequencies. So putting x equal to 1, 0, 1, 2, 3, 4, 5, 6, 7, 8 in the binomial probability function, we get all these terms. So you need to write down like this. You may sometimes you may need to prepare a table. Sometimes you may not. Depends upon the situation. Do wisely. Right now I am not using any tables. It is perfect if you write down as per a table format. That will be much better rather than free writing. So first one, let us begin with number of heads. First one, if you are getting no heads, that is the value of x is 0. So the equation is, we all know the equation, binomial distribution function of ncx into p raised to x into n minus x. So n is 8. It is already mentioned in the question. 8 coins are tossed. So n is 8. X equal to 0. 1 by 2, we already found the probability of getting a head is 1 by 2. Or whatever may be the question or case, the probability of getting head is always 1 by 2. So 1 by 2 raised to x. Raised to x means here it is 0 into 1 by 2 raised to n minus x. N is 8 minus x is 0. You will get 1 by 256. And in the question you are asked to find the expected frequencies of head. How many times the head occur? You have found that the probability of not getting head is 1 by 256. That is in a fraction pattern. You need the exact number of times no heads come. So in order to do that, you have to do one property. That is, if you multiply the n, capital N, with the probability value, you will get the expected frequency. So expected frequency is P of x. P of x is 1 by 256 into n. In this case, the capital N is 256 times. So into 256, you will get 1. That is 1 by 256 into n. N means 256, you will get 1. Because 256 and 256 cancelled and remaining value is 1. That is how you have to find the expected frequencies. Next one. If the number of heads is 1, it will be like this: 8C1 into 1 by 2 raised to 1 into 1 by 2 raised to 8 minus 1. You will get 8 by 256. That is the probability of getting one head. But you need to find expected frequency. Expected frequency means probability of that particular event, that is 8 by 256 into total number of events, that is n, capital N, not small n. So 8 by 256 into 256, you will get 8. So you have found the expected frequency of if you are getting one head. Next one. If you are getting two heads, again the same pattern, the same method: 8C2 into 1 by 2 raised to 2 into 1 by 2 raised to 8 minus 2. You get 28 by 256. If you multiply 256 with this one, you will get 28. So you have got the expected frequency if you are getting two heads. Next one. Three heads. Same pattern: 8C3 into 1 by 2 raised to 3 into 1 by 2 raised to 8 minus 3, that is equal to 56 by 256. So you have got the probability of event 3. Event 3 means when 3 heads come. So if you multiply it with capital N, that is 256. Here number of items is 256. That is why 256, you will get 56. Next one. When number of heads is 4, so it will be 8C4 into 1 by 2 raised to 4 into 1 by 2 raised to 8 minus 4. You will get 70 by 256. If you multiply it with 256, you will get 70. Next one, when the number of heads are 5. So 8C5 into 1 by 2 raised to 5 into 1 by 2 raised to 8 minus 5, you will get 56 by 256. So you have got a probability of event, that is number of heads 5. If you multiply it with 256, that is capital N, you will get 56. And finally 6. Again the same pattern: 8C6 into 1 by 2 raised to 6 into 1 by 2 raised to 8 minus 6, you will get 28 by 256. Then multiply it with 256 is equal to 28. Next one, 7. 7 means if you have tossed a coin, 8 coins simultaneously, what is the chance of occurrence of getting 7 items or 7 coins as head? So 8C7 into 1 by 2 raised to 7 into 1 by 2 raised to 8 minus 7, you will get 8 by 256, that is 8. And finally 8C8 into 1 by 2 raised to 8 into 1 by 2 raised to 8 minus 8, it is 1 by 256. If you multiply it with 256, you will get 1. So this is how you have to find the expected frequency. Whenever you are asked to find the expected frequency, or whenever you are asked to find how to fit a binomial distribution, you have to follow all these steps. And we are not complete, because in the question it is said that 8 coins were tossed together 256 times, and we have found the probability of each of the individual cases and find expected frequencies. We also found the expected frequencies, and finally find mean and standard deviation. So what is the equation of mean with regard to binomial distribution? We have learned that, and we also know the equation of standard deviation. Whatever the case, for mean and standard deviation, you need to know the values of n, p and q. So just substitute the necessary values in the equation, you will get the value of mean. We know that mean is n into p. We already found that n is 8. See, n is 8 into p is 1 by 2, you will get 4. Next one, standard deviation. We know that the equation is root of npq. that is root of n is 8, p is 1 by 2, and q is also 1 by 2. So 8 into 1 by 2 into 1 by 2, you will get 1.414. So you have found the value of mean, value of standard deviation on the basis of details given in the question, and this is how you have to find the expected frequencies. And in this question, 8 coins were tossed and 256 times, it is all given in the question. Sometimes this 256 may not be given. You might be given the details of x and f, that is x will be given. X means this one 0, 1, 2, 3, 4, 5, 6, 7, 8, and frequencies will also be given. Frequencies mean what are the chance of events, that actual events that have occurred. You need to find expected. Sometimes actual events may be given. So in that case, when actual event is given, in that situation capital N, that will not be given. That is in this situation 256. Then how you are going to find that? Very easy. Just add together the values of f, because total of f is known as capital N. If you remember the statistics which we have learned in the last sessions and last semester, you might get the idea. N, capital N, means total of f. We will come to that part and we will discuss about that during the application level case. So just go through it. We will discuss about the next case. Next one. The following data show the number of seed germinating out of 5IB dam filter for 80 set of seeds. IB dam filter is it's a technology or a technique that used for germinating seeds in a practically situated and is practically created or simulated environment. How seeds can be germinated artificially in a lab oriented setup. It's actually a technical term, we need not worry about the term. The thing is that number of seeds germinating out of 5 IB dam filter for 80 set of seeds. Fit a binomial distribution of this data and find the expected frequencies. Apart from that, in the question it is given that x is given because germinating out of 5 IB lambs. So we have got the value of small n, that is known as x. X is 0. Apart from 1, 2, 3, 4, 5, you need to find extra 0, about 0 event. And the frequency is also given. Chance of occurrence of f is 6. Occurrence of 1 is 20. 2 is 28, 3 is 12, 4 is 8, 5 is 6. So you may think that here the frequencies are given, so why we have to find again? These are the actual values that are analyzed or found out on the basis of the actual occurrence of the event. You need to find the expected frequencies on the basis of this data. These are the actual values. You need to find the standards, just like the word which we have learned in case of management. Actual events, standard events, actual and standards, comparing actual and standards likewise. So these are the actual values. On the basis of that, you need to find the expected frequencies. So for finding the expected frequencies, you need N, you need P, you need Q. In this case, N is there and capital N is also there, and remember, if you add together all these values of f, you will get 80. So can you find the expected frequencies on the basis of these data? No, we have only the value of n, small n. We need not have to deal with capital N now, but we need it during the computation part. But for initial computations, we need n, p and q, and we have only n. So how you are going to find P and Q? For that, you need to use the method, statistical method of finding the mean using the equation of finding the average of a mean. So I hope we all know the computation method for finding the value of mean of a certain series. Follow that. So on the basis of that, you will get the value of mean. Before that, try to convert the same in the table. X is written, F is written. If you remember the methods which we have learned in the case of third semester statistics, you might remember this is a basic individual series situation with regard to mean, computation of mean. First you need to find the mean, because we don't have any details about P or Q, so you have to go with the mean. So X is written, F is written. This is an individual series, so I am using the first mean method of finding mean. You can use any method of finding mean, either individual series or discrete series. It's up to your discretion. Since it is a frequency distribution situation, it is a discrete series, so let us go with the discrete situation. So X into F, you will get Fx 0 into 6, 0. If you multiply the values of X column and if you multiply it with the frequencies column, you will get the value of Fx. If you add together the columns of Fx and F, you will get 174 and 80. So the value of mean of this particular series is total of Fx divided by total of F. We have learned this method. We are not going further into that. You will get the mean of the series as 2.175. So on the basis of that, you can say that NP will be 2.175 because the mean of this series is 2.175. And we also learned that in binomial distribution, mean is represented by NP. So now we have NP equal to 2.175. And we also have the detail or the value of n is 5. So you can easily find the value of P. So by substituting it, let us substitute the value of n in the binomial distribution equation of NP. So NP equal to 2.175. So 2.175 equal to 5P and P equal to 0.435. And if you know the value of P, you can easily find the value of Q. I hope you know that concept. So now we have P, Q, N and also the mean. So now we can easily find the expected frequencies of each of these values. So let us write down the details we have found in the question as well as the values which we have found now. Capital N is 80. This is already given. If it is not given, just add together the values of frequencies. 80. See, 80. And small n is 5, P is 0.435, Q is 0.565 and the X is 0, 1, 2, 3, 4, 5. So we have got all the values or required for finding out the expected frequencies with regard to binomial distribution. Just do as per the method which we have followed in the previous one. X column, probabilities of each of the X events, expected frequencies. It's better you draw a table for during the computation. That will be much better rather than the freehand written pattern which I am following. So in the exam, try to draw a table. So first one, when the event was 0, so the value of X will be 0. By substituting the same in this case, 5C 0 into 0.435 raised to 0 into 0.565 raised to 5 minus 0. So you can see that in the equation it is 80 into this one. How did the 80 came? The concept is for finding the expected frequency, whatever the probability under the study of the particular event, you just multiply it with the total number of frequency or total of F or the capital N, which is already given in the question. If you multiply directly, you can get the expected frequency. In the last question, I have done this step here. That is only difference. I just multiply right from the beginning. So 80 into 5CX, X is 0 into 0.435 raised to 0. Until previous question, we have been dealing with the P. Usually it will be a fraction. So don't worry about it. You can either use a fraction or you can use a decimal. The thing is you have to do the superscript values correctly. So 0.435 raised to P raised to X. That is the meaning of 0.35 raised to 0 into 0.565 raised to N minus X. N is 5 and x is 0, and you will get the expected frequency with regard to event 0 is 5. So likewise, when the event is 1, 80 into 5c1 into 0.435 raised to 1 into 0.565 raised to 5 minus 1, you will get 18. Likewise, next one, second event, 80 into 5c2 into 0.435 raised to 2 into 0.565 raised to 5 minus 2, you will get 27. And next one, third event, 80 into 5c3 into 0.435 raised to 3 into 0.565 raised to 5 minus 3, you will get 21. Next one, for event 4, it will be 80 into 5c4 into 0.435 raised to 4 into 0.565 raised to 5 minus 4, you will get 8. And finally, it is event 5, 80 into 5c5 into 0.43 raised to 5 into 0.565 raised to 5 minus 5, you will get 1 by 2. In the text, these two values are different. Just try to work out these two statements alone separately, then you will get the value 8 and 1 by 2. So please make the necessary correction in the text. So this is how you have to find the expected frequencies with regard to the case under study. So in this case, you have to find mean in order to find P and Q. Then only you can use the binomial distribution function to find expected frequencies. So just go through these cases, understand each of the scenarios. Don't worry about the computations, just understand the concept, because you will be dealing with the similar pattern questions, but you need to familiarize the concept and case. So just go through all these methods. We will discuss further about these situations and various types of distributions under the study. So we have almost dealt with various methods under binomial distribution. We will discuss about the further cases under different distributions under the theoretical distribution concept. So go through it. We will see you soon.